It's time to upgrade your 2017 and newer L5P turbocharger with a 67 G2. Hi, I'm Nick Priegnitz. You know, the L5P has been on the scene since 2017. Very strong platform, the base long block capable of holding 1,000+ rear wheel horsepower in a competitive atmosphere. Strong fuel system. We've seen over 700 rear wheel horsepower in competition. You know, really the truck is Lambda limited. It's got a strong transmission, holds up to 550 horsepower, 1,200 foot-pounds continuously. But the air supply is where we need more for those guys looking to push on the trucks routinely or looking to make more power than that 550. For those reasons, the turbocharger has been an especially critical part of our development on the L5P platform. We found out early on that being Lambda limited means the more air we can get in this thing, the better the ambient conditions for airflow, the happier this truck's going to perform. Really, everything else is there except for the air. On the plus side, we've got a lot of years designing turbochargers in the Duramax market, and we know what it takes to get there. What's different on this Borg-Warner unit is the exhaust side. So you look at the front of this turbo, the first thing you see is this big electronic actuator. What it does is control the vane cage, the nozzle ring assembly, whatever you want to call it. There's a few different ways to refer to it. What it is a mechanism that controls the shape of the exhaust gas flow onto the turbine. And it does that by moving this unison ring and changing the angle of these vanes as they direct airflow onto the turbine. As these change, the opening size changes and the angle of that airflow on the turbine changes. Now we can close the vanes up like so and get a really aggressive high velocity airflow, high exhaust pressure but high velocity quick spool up. And we can start to open the vanes as RPM and load comes up, and that's going to allow the exhaust to breathe more and really get a lot of exhaust mass moving through the system and allow the truck to breathe up top. That's the beauty of the variable geometry turbocharger system, is you get good response and you get decent performance up top. Now when you want to go even higher in performance, now of course you need to address the compressor side. We look at the front of the turbocharger, the compressor wheel needs addressing. That's the only way you're going to allow more mass airflow through the system. But that exhaust side is the hardest part. Let's start with the easy stuff. Stock compressor wheel on the L5P, 61mm 11 blade billet wheel. Good for about 60 pounds of air through a factory airbox. In testing, that results in about 550 rear wheel horsepower on an emissions equipped truck. Maybe a little bit short, maybe a little bit more depending on ambient conditions. Really you're going to be what we call Lambda limited, and that means that we're going to limit the truck based on the air fuel ratio that the truck is burning at. So as you run out of airflow, we're going to start to pull fuel back and not allow the truck to fuel more. If you're in a competitive atmosphere and you're not concerned with Lambda limits and you want to run in the gray haze area or the smokier area, that turbocharger can make up to 600 rear wheel horsepower. And that's really working the truck, really working the fuel system. It's not an efficient setup, but it'll make the power. Now as we look to make more power on these emissions equipped trucks, of course we need more air. So we stepped up to a 67mm 11 blade billet wheel. And what that does is allow us to go from moving 60 pounds of air through the airbox up to 80+ pounds of air through the airbox. So 82 pounds as we've measured on the factory MAF sensor. That 82 pounds of air, well, that's a key ingredient in making big power and big torque, and doing so efficiently. Moving efficient air through the compressor side is great. The best match for that is moving air efficiently on the exhaust side. And that's where we come into the part that really stretches the engineering and design on this project. So what we had to do was design a larger turbine wheel. So we go from a 69mm by 9mm wide wheel on the stock L5P up to a 77.5 by 15 wide on our 67mm. That's a huge bump up in turbine size. What that does is allow us to run drive pressure to boost pressure ratios that are much more in line with what they should be at that higher RPM and higher power numbers. Remember, the turbine is the engine that drives the compressor wheel. If you don't have an engine capable of spinning that bigger wheel, you're going to be relying on pressure and you're going to be relying on choking those vanes down. And when you do that, a lot of the power that you gain from the big compressor wheel, well, that gets used up in the exhaust. If your pistons have to fight 90+ pounds of drive pressure in the exhaust system, you're going to eat up horsepower. So yes, the crankshaft is making that horsepower, and there it goes back into the turbocharging system on an inefficient setup like that. That's why we're looking for a nozzle ring and a turbine assembly that runs at low boost to drive ratios and is really efficient on the top end. How do we do that in the nozzle ring side? Well, I showed you the factory nozzle ring before. It's 9mm wide. That means all your exhaust gas flows through that 9mm opening and then is angled onto the turbine wheel. Our nozzle ring is 15 millimeters wide, and it's larger. But it allows the same control, same variable geometry operation, uses the same electronic actuator, which means you get the same great response of the factory turbocharger. It's just when the thing starts to get rolling, we can open this up, get out of the way, and take advantage of the big efficiency on that big turbine, get those drive pressure numbers down, and keep this thing happy. We're able to see the turbine open up to 20% down to 0% vane position at full tilt. And that's still with that big airflow number, 80 pounds plus. What that means is that the turbine assembly is happy. We like to see that. Keeps the bellows happy, keeps the gaskets happy, keeps the engine happy. As far as numbers go, you've heard the numbers on the turbine and the compressor and the nozzle ring, and how does all that translate, right? Well, we've talked a little bit about peak airflow numbers. Now those are peak power numbers. Most of you guys using your truck, you're interested but not terribly concerned with peak power numbers. Guys using that power daily, towing, this is where that negative feedback loop that we talked about in the towing comparisons video really comes in. When you're doing 0 to 60 runs or you're pulling a trailer up a grade for 8 miles straight, the truck is really concerned about how much heat it's making. So an inefficient compressor, an inefficient exhaust is going to start packing the intercooler full of heat. Now you might be making a lot more power on that first mile or first half mile, but as the system gets backlogged with heat and it can't reject out of the system, that's when the safeties kick in and you start to lose that power. You start to lose the ability to pull that grade as well as you were. With a more efficient turbocharger, we're able to move more air through the system more efficiently at lower temperatures. Lower temperatures means you get to take advantage of those high power numbers for longer. Furthermore, your exhaust system, your emissions equipment, a lot happier because we're running better air-fuel ratios, meaning we have more airflow through the system. We're running leaner, and what that means is less particulate matter, happier DPF long-term, fewer distances between regen. Overall, the system's just happier at higher power levels. If you've been waiting for that L5P turbocharger upgrade that lets you have your cake and eat it too, this is the one. We spent the time, we did the research, we built you the unit you want. Give us a call, talk to one of our knowledgeable sales reps today. I'm Nick Priegnitz at DuramaxTuner.com, 815-568-7920. Thanks for watching.